Okay, here we go. Doing these problems. So as I was thinking about the lesson and thinking about how weird this stuff is going to get, sometimes you have to watch the lesson and then come do the problems, and they're still part of the lesson. They're still part of like building the understanding of what this is. So I know the lesson was pretty boring. I feel bad about that, and it was long too. Well, it is what it is, I guess. So let's start with number 3. Number 3 has us saying we have this sequence that is the sine of n pi over 2. Give the first 5 terms. This seems like a waste of time. I would imagine it seems kind of easy for you. That's okay. I just wanted to make sure you really fully understand the process of getting the first few terms, especially with number 5, but even with number 3. Pardon me, write the first 5 terms of the sequence. So they don't even tell us really where to start. And I'm going to start with 1 all the time unless I'm told otherwise. So just to make sure this is really clear, I'm literally plugging in n equals 1, and then n equals 2, and then n equals 3, and so on. And that's how I'm getting the numbers in the sequence. So when n is 1, we have the sine of pi over 2, that's 1. When n is 2, I have the sine of pi, which is 0. When n is 3, I have the sine of 3 pi over 2, which is -1, and so on. And the answer is already there. Number 5, I wanted to point out this thing, the -1 to the n plus 1. We're going to talk about it again in more detail, but I call this an alternator. When I see -1 to a power of n, even if the power is n plus 1, I know that that's going to make the signs of my numbers in the sequence alternate. Negative, positive, and so on. So it's different than up here. In this one, I have a positive and a 0, then a negative. That's not alternating because it's not going every other one. But in this case, with this thing, my signs are going to change every other one. Positive, negative. Doesn't mean I'm going to start at a positive necessarily. It just depends on what my first value of n is. So anyway, we're going to have n equals 1, n equals 2, n equals 3. You do not need to write that out. I'm just writing it so you're really clear on what I'm doing. So when n equals 1, I'm plugging 1 in for n. So I'd get -1 to the second, which would be +1. Plugging in 1, I get 2. Now I'm going to plug in 2. When I plug in 2 into this, I end up with a -1 times this. 2 over 2 is 1, so I end up with -1 altogether. Plug in 3. Now I have -1 to the 4th. That's an even number. That's an even amount of negatives, so that's positive. And then plug 3 into here, and I have 2/3. N is 4. Plug 4 in, I'm going to have negative. Plug 4 in, I'm going to have 2 over 4, so 1/2. And then the last one turned out to be 2/5. 3, 5. Okay, so the 9, 10, 11, and 12, I hope that they were okay and made sense. Here are the problems. I'm matching these with the series, the sequence that they represent. So see again that little idea of an alternator here with 11 and 12. 11 and 12 tells me that my signs are going to be changing, positive, negative. But look at the difference between them. Number 11 is just -1 to the n. That means the terms of my sequence are just going to be -1, 1, -1, 1, -1, 1. That represents this. This sequence would diverge because I don't get closer and closer to a specific number. I just keep oscillating back and forth. Whereas number 12, I have -1 to the n, so I am going to be changing signs back and forth, but over n. Or you could think about this as -1 to the n times 1 over n. So now my numbers are changing signs every other, but the numbers are getting smaller and smaller. That's this. This does converge because my numbers in my sequence are getting closer and closer to 0. They're oscillating around that x-axis, but also truncating, also coming in and getting smaller. So that's the big difference there. These two, between 9 and 10, well, number 9, this is definitely getting smaller. So 10 over n plus 1. The bottom has an n in it, the top does not. So that means the bottom is getting bigger, but the top is not. The top is remaining the same. So since the bottom of the fraction is getting bigger, the overall number is getting closer and closer to 0. So that's this, we're heading down. Whereas for number 10, we have that idea of looking at the degree of the top and the degree of the bottom. So I have n to the first and n to the first. So since these are growing at the exact same rate, I have to take the ratio of the coefficients. This is how we used to do horizontal asymptotes. So this should have a horizontal asymptote at 10. These should be getting closer and closer to the number 10. We'll look up here. The values are getting closer and closer to flattening out here at that, kind of horizontal asymptote at 10. I don't think I really went over that much in the video, and it's going to come up again doing these problems. But when I'm thinking about how is this growing, the growth rate of the top and bottom are the same, n to the first, top and bottom. This +1 means nothing. That really doesn't change anything at all. I get to just not worry about that. I only worry about what we call our lead terms. So 10n over n, I can think about the n's almost as like reducing out, canceling out, and leaving me with 10, which means this is going to approach 10. So hopefully you kind of remember that. Okay, number 29. So now we get into actually deciding, do these converge or do they diverge? If the sequence converges, find its limit. So we have 5 over n plus 2. So I want to look and see which is growing faster, the top or the bottom. Well, the top is only a constant, the bottom has a variable, so the bottom is growing faster. That means that the limit as n approaches infinity of 5 over n plus 2 is 0. So that means the sequence converges to 0. That's all I'm doing for each one. I'm deciding which grows faster, the top or bottom. If the top grows faster, the sequence will diverge, too big. If the bottom grows faster, the sequence will converge to that number. And if they grow at the same rate, the sequence will still converge to that basically ratio of the coefficients. So let's look at a couple more. 31. So now we have -1 to the n over n plus 1. Why does 31 say? Oh, okay. Got it. Okay, so this one's a little tricky. Let me just say first, if it didn't have this, then the limit would be 1. But because I, same degree top and bottom, so when I reduce that, I take the ratio of the coefficients and I get 1. But this alternator screws things up. And the reason for that is the limit becomes 1 or -1, basically. Like I have a limit that of this thing would just be 1, but once I put the other sign in, it's -1. This becomes an oscillating sequence. Try plugging in some numbers and see what happens. I should get a positive and then a negative and a positive and then a negative counterpoint. And I just keep going back and forth between getting closer and closer, getting closer to 1 on the top and -1 on the bottom. But that doesn't help me. I need to get close to the same thing as I go through. That one's a little tricky. You won't see that come up again, but I still like it. 33. So here's that example of I don't have an alternator now. So 10n squared plus 3n plus 7 over 2n squared minus 6. So first, look at the growth rate. I don't care about any of this. I don't care about this. I'm going to compare the lead terms on the top and bottom. So since the degrees are the same, this is going to converge because I don't have that alternator. I'm not going to be alternating signs. I only get to worry about this, and I'm just thinking about where does this have a horizontal asymptote? That happens at the ratio of the coefficients. So this is going to converge to 5 because the n squareds are going to cancel each other out, and I'll be left with the 10 over 2, which reduces to 5. $35. The natural log of n to the third over 2n. Okay, I thought about this for a little bit, and I was like, which grows faster, the top or the bottom? And I looked at the top, and I thought, well, this is n to the third, and this is just n. So I thought maybe the top would grow faster, but this isn't n to the third. This is the natural log of n to the third. We don't care what I'm taking the natural log of. It's still a natural log. This grows more slowly. This grows faster. My bottom is still going to grow faster than the top because the top is a natural log. It's a natural log of this cubic, but that doesn't matter. It's a natural log. So the limit is going to equal 0, the series is going, or the sequence is going to converge to 0. $37. We have n, oh, did I give you this? Plus 1 factorial, I guess I did, over n factorial. This is a, don't stress about this one. I probably shouldn't have. I'm laughing because I shouldn't have even given you this. You would almost be apt to say that this converges because you're looking at like the lead term, but it doesn't work that way with factorials. So the top is bigger here. This top factorial is bigger than this bottom factorial, so this is going to diverge. Don't worry about that. I probably shouldn't have given it, but oh well. 41. 2 to the 1 over n. The answer says converges to 0. 2 to the 1 over n. So I don't have a bottom and top. I just have a fraction as my exponent. So as n becomes infinitely big, this fraction becomes 0. So really, the limit as n approaches infinity, I would say, is 2 to the 0, which is 1. They said it converges to 0. Maybe I didn't look up that answer right, because when I put the answers down, I didn't do the work. Let me just double check, sorry. 9. Number 41. Oh, there we go. Converges to 1. Okay, I gotta go check that, fix that answer. When you see that now, actually, I'll fix the answer in just a second, so you'll see it already corrected. So you're gonna be like, why is she saying that? Because I had to go fix it. Okay, so yeah, it converges to 1. So because look at that fraction, as the bottom gets really big, that fraction becomes 0. So this really is acting like 2 to the 0, which is 1. All right, 43. We've got the sine of n over n. So which is growing faster, the top or the bottom? Ugh, I don't know. Well, the bottom, right? Because sine is never going to get bigger than 1 or less than -1. Sines, think about what sine is. It just goes back and forth between them. So we get values between 1 and -1. But n is going to grow exponentially, infinitely, not exponentially. It's just going to go to infinity. So this is going to become infinity, and this is going to stay between 1 and -1, and all the values in between. So we are going to get 0 in the end. That limit is going to be 0. Oof, that's pretty out there as well. See, stuff is out there. All right, 45. Okay, so 45 and 49 and 52. I'm not sure what you're going to think about these. We're going to end up having to write these things a lot eventually. So I thought this was a good place to start, but I don't think I would have pulled 45 out of my own head. So 45, the sequence is 2, 8, 14, 20. And they want you to give that like nth term notation for that. Usually we're looking for like powers. Well, I might have started by saying this is 2 to the 1st, this is 2 to the 3rd, but that's not 2 to the 5th, so that doesn't work. I don't know, this is 2 times 1, this is 2 times 4, this is 2 times 7, this is 2 times 10. Oh, maybe now I'm seeing something. So, oh yeah, I like this. I'm looking at their answer. So by the way, these answers can vary. So I would actually say that our sequence is made by doing 2 times, how would I write this so that it would work for everything? 2 times, it can't be n plus 3, right? because that's a 4 and a 7. It's like I'm adding 3 each time to the number that's getting, but that's not going to do it for me. Yeah, you maybe see what I'm thinking, but I'm not sure how to like write that as a formula that will get me each number. So that there are ways to do that, but it's kind of complicated. So that one's not going to work. So what they came up with, I don't know. I would never come up with it myself. 6n minus 4. They're saying the answer is 6n minus 4. So when n is 1, I get this. When n is 2, yep. When n is 3, wow. There's another one that I'm not needing you to be able to do that at this point. There's some stuff, it's called recursively defined functions. There's some stuff we could get really like take a deep dive into. I don't want to, there's no point because we really don't need this moving forward. So for number 45, just be comfortable with understanding that does work. It gives me every term in the sequence. Coming up with that yourself, meh, not really. Let's see if 49 is better. So obviously I chose these before I did them all. So 2/3, 3/4, 4/5, yes, this one we can get. 5, 6. So how would we write this? Well, they wrote it one particular way because they're always starting with n being 1. We don't always have to start with n being 1. I can say, let's start with n equals 2. And then I can say that each number would be n on the top, n plus 1 on the bottom. So when n equals 2, I have 2/3. When n equals 3, 3/4. When n equals 4, 4/5. Or they started with n equaling 1. So then they had to say the top term is n plus 1, the bottom term is n plus 2. And they got that. Either way is fine. You will notice with some stuff moving forward that there are multiple ways to give an answer. Either one would be fine. $52. Again, there's probably multiple ways for 52, but 1/2 times 3, 2 over 3 times 4, and so on. So because we start with a 1 here, this shouldn't be too bad. The top number is n. The bottom number is the product of 1 more than n and 2 more than n. And that would get you every single term. All right, and finally, number 72 says the graph of two sequences are shown in the figure. Which graph represents the sequence with alternating signs? Hopefully you were pretty good with that because of looking at 11 and 12. Which one's alternating signs? This one. Positive, negative, positive, negative, positive, negative. Duh, these are all positive, but just decreasing. So that's it. All right, I hope they feel okay. It's okay if you don't feel great. This stuff's weird. When we move on to series next, which just draws on this concept. So the basic things to understand of this are, how to take this and write out the terms, how to tell if it converges or diverges, basically just what grows faster than what. Yeah, hopefully we'll all be okay.